I'm Sean Seeley, and I'm just going to tell you where we started now and where we are now. Just give you a brief overview, then let the rest of the team fill in the gaps. Initially, we brainstormed. Everyone had completely different ideas, and the ideas mostly involved keys with levers used in various ways to cover the holes. One idea had a slide mechanism to cover the holes. We had a collar that could be rotated, similar to the sheath idea. One idea with a device to support the recorder while she was playing it, so she wouldn't have to focus on holding it, she could just focus on playing. But no concept was complete, and some of them weren't feasible, and we couldn't get anything really together. We're feeling really discouraged. It all seemed pretty impossible at the moment. But the main thing we're struggling with was the concept that Naya had to be able to perform multiple functions simultaneously with her wiggle that could only do one thing at a time. We had a group conversation and realized we're focusing on the wrong thing. We were trying to make her cover the holes on her own by using keys, which are basically just an extension to the hole. So it was just an extension of the problem. It didn't solve it. And at the same time, Will found a video when he was benchmarking of a recorder that was played by a computer using servos, and it just would give a signal to play a different note. So at that moment, basically, what we said is that the light bulb turned on, it all came together at once, and realized all we would need to do is mount some, we changed the solenoids over the top of the recorder, and she could just activate the solenoids in order to play different notes. So the idea was the least of the work, which initially we thought that'd be the hardest part, but fine-tuning it is proving to be the real challenge. And I'll pass it off to Clark to let him talk about the solenoids we're going to use.
Alright, so this is a CAD of our solenoid. We found it on Amazon for like $8. We're going to use 4 of them. They're going to cover the holes that you'd normally use with your finger on the bottom 4 holes. If you don't know what a solenoid is, it's basically a device that converts electrical energy to mechanical motion. And our solenoid was chosen on its low power requirements, its low weight, and its cost effectiveness. And then we were deciding if we should use servos or solenoids at the beginning, and we decided solenoids because they can act fast and they're a lot cheaper.
So I took care of the solenoid mounting. We had 3 different ideas at first. We had a side mount with levers, top mount just straight down, and a bottom mount with levers as well. We wanted to make it as light as possible for her, as well as like the easiest way for her to hold it. And over here's our mounting design, the top one, and we went with the top mount, so we didn't have all the extra levers and stuff. Next we have a video of the solenoids actually working. This is when we first tested them out in casing.
Yeah, I don't know how to make that video play.
Scroll over. Yeah. See, they're pretty fast. We'll cover all 4 holes.
Obviously that was just making all of them go at once, but we're going to have to have activated so they play different notes.
One of our main problems was how to control the solenoids. So we came up with a keypad idea. Now this is we're still in thought about this but basically there's different options for keypads that we've been looking up. One of them is heat, one of them is touch, there's motion sensitive, there's a bunch of different ways we could go with it. Right now that's our keypad we have at the moment. So pretty much our goal is to have 1, 2, 3, 4. It could be like the bottom 4 notes, and pretty much, if you want to go to the next slide, we're going to have some sort of microcontroller, which is also still in design. So when she hits one of the buttons, it closes the required solenoid for each hole. Right now, our current keypad requires 0.03 amps, but we need a keypad capable of having 1 amp flow through it due to our battery and solenoids. One of the things about that is we thought about using a couple different methods, maybe a relay or a capacitor type, so to speak, to step the amperage down and back up. But that's one of the things we're going to have to work on next semester. We're also working with a couple of EEs, our electrical engineers, to figure out the microcontroller for the keypad and the solenoids. So when she actually presses one of the keys on it, it closes the right solenoids. I'm going to hand it off to Will.
So my name is Will. I did the mounting clamps, and initially we had decided to try to use standard parts and went with a ground clamp because it looked like it would work. And we found that it was very, very heavy and very clumsy on the end of it. And the teeth on the ground clamp marred the finish on the recorder, so we knew that wasn't a viable option. So I decided to make these squeeze clamps just by taking the diameter of the recorder, and it would slide up to that point where she could tighten it down with wing nuts, and the mounting rail that the solenoids would mount in between the two fingers, if you will, for the top. So for the bottom, it posed another problem. There's a bell on the end of the recorder, so we needed a way to open the recorder clamp and then close it over the recorder. So we made a two-piece clamp in the same fashion as the solid one-piece clamp. And I'll hand it off to Mark.
The battery that's going to power the solenoids and the keypad, we went with a 12-volt, 1.2 amp hour sealed lead acid battery. And we found that each solenoid draws about 0.3 amps. So if she were to simultaneously hold all three solenoids, activate all three solenoids at the same time, that would give her roughly an hour, which she won't be doing, so she'll have over an hour roughly to be able to play and practice. We're also going to provide her with a battery charger so that when it does need some more juice, she can plug it in. And we're still in the process of trying to decide where we're actually going to place the battery. We've discussed possibly attaching it to her hip so that she doesn't really have to bear too much of the weight. And to support the vise, we're going to modify, this is typically used to support a harmonica. So by modifying that to support the recorder, she won't have to physically support it herself with all the extra weight of the solenoids. And let's see, Ryan is going to finish up with a summary.
I'm Ryan. To wrap this up, we wanted a design that was simple, easy to use, and didn't require a big learning curve. And after many different designs and getting inspiration from similar systems out there, we decided with the solenoid keypad combo, where each button, you press a button and it closes the proper holes to complete a note. Looking ahead, we're going to need to focus on a few things to make this perfect. One of them just mentioned was how we're going to control the solenoids to actually cover the holes. We're looking at microcontrollers, possibly like an Arduino board or something. We're also going to narrow down our choice for the material to cover the holes. Some of the things we're looking at are neoprene and cork and felt, which is what's used in most flutes. The spacing between the holes and the material when the solenoids are open is also a critical part. So there's enough space between to allow airflow that it won't impede on the actual sound of the recorder. That's it.
Any questions?
What kind of forces do the solenoids put out?
4 newtons.
Okay. And the stroke?
Centimeter?
10 millimeter.
Yeah.
We have to end it there. We want to have some, let's move it past. You guys can take 5 minutes for evaluations. We appreciate it.